Thank you for your time today, everyone. It's really nice to see so many people come to hear about this. It was a really interesting project, and I hope I've got some information to tell you really about the. I'm focusing today about the methods that we applied to try and understand what the social environmental impact is of food waste, and how it's possible to assign a value to that. Really, so very quickly, just to describe the waste fuel project, which Jan has outlined really, but to say that what we're trying to do was in this quite large consortium was how to explore the benefits of making efficiencies in the food, energy, water nexus, and specifically how we can reduce the socio-economic and environmental impacts of food waste from my point of view. So we had 4 urban living labs in Bristol, Rotterdam, Cape Town and Sao Paulo. And in Bristol, we worked with a number of different partners, including people like Wessex Water and the people that run some of the big waste processing facilities there, Bristol Waste and Genico. But we also work with the Bristol Food Network and Coventry University had a really important part of this as well. So we all collaborated to try and understand this area. So the one I had quite a small, relatively small piece of work around just trying to define that non-market value of those impacts of food waste in Bristol. So just to kind of outline the problem here in terms of food waste in the UK. What we're looking at in the UK, it's been defined as around 9.5 million tonnes of food waste every year, which is equivalent to 10 million cars just in greenhouse gases, just in the equivalent of CO2 emissions. So it's a really, and just households contribute around 6.6 million tonnes of that. So about 30% of food waste is not edible, which is sort of things like fruit peels, bones and things like that. But you've still got this huge amount of waste and this huge resource really that could be saved. So what we wanted to do was trying to describe that ambition, which we specified, which is a 20% reduction in food and drink waste, which is something the UK government is committed to by 2025. So we wanted to explore what the efficiency basically might be of that. So I really wanted to talk about how we would go about valuing impacts on the environment and human health, and then how we describe those impacts through a life cycle analysis, and then how we'd apply that to the context of Bristol, and then show you a few of those results, and then maybe talk about some of the limitations with doing that method. So very quickly, our research questions were just what are the non-market and environmental benefits of reduced food waste across the food waste cycle for Bristol, and what reductions in energy and other resources could be saved by reducing waste by 20%. And within that, we also had a question there about is it more efficient to reduce waste, or is it more efficient to recycle waste as well? So that's a kind of sort of sub question that we had in order to help give that information to our stakeholders. So I wanted to start by just talking a little bit about what non-market valuation is. So what is to describe costs which have no normal market value, or that you can't observe through a normal market function, such as human health, happiness, biodiversity, and intangible assets such as the spirituality and historical meaning of places, and to understand a little bit about how what impact that has when those resources are reduced or compromised in some way. So in order to use that, we can't establish those by looking at normal markets as you would for perhaps the price of a house. So what instead we look at is people's preferences. So we used try and uncover people's preferences through a series of different experiments like choice modelling or contingent valuation, where we try and ask people how much they'd be willing to pay or to accept for a change in the environmental quality. So, so really, it's trying to define that that point of the value of what people place on those intangible assets. So, and the units that we're going to be using slightly later on to define these environmental impacts. This is just an example of how we do that with carbon and climate change. So the unit that we express for climate change, and this is sometimes referred to as global warming potential, is CO2 equivalent, and that's in terms of the pounds per tonne of CO2 equivalent. So what this is, it's an abatement cost. It's an attempt to value the damage costs associated with climate change and what we might need to do in order to reach our targets for 2050. So it doesn't actually cover the whole cost of what climate change might do and what an additional tonne of CO2 might do in the atmosphere. We know at the moment the value of this unit is very low and it's very uncertain. There's a lot of debates around carbon and climate change, but we know that that value is likely to go up almost fourfold by 2050, just referring to the report that we use to define climate change in this instance. So similarly for human health, we use here a unit which describes the effect that different chemicals in the environment have on human health. And here it's described as a comparative toxicity unit. Some of them use an equivalent unit based on a particular chemical which is used in things like toilet fresheners, which doesn't degrade very well in the environment and therefore is associated with a number of effects on human health. But that's a midpoint which is used to describe many different chemicals and the impact that that has. So it's trying to come up with units that describe different effects on the different effects as a result of food waste and the resources that go into food. So what we try and do is understand all of the resources that go into food from land use change, from farming, so from moving from farming forests to perhaps soybeans, all the way through from processing to retail to households, moving food around, and then to the waste disposal. And the implications of what happens when you dispose waste and how it's disposed of. So one key piece of information that we have here is from this study, which carried out a life cycle analysis of all food waste in the UK, which is this Tonini study from 2018. So what this study did was explore those things for around 10 different categories of impact on the environment. Across 4 different sectors. So we had not just households, but the processing sector, the retail sector as well. And it also looked at lots of different points in the chain, in the life cycle chain of food as well, and how what different points contribute to that overall impact and that overall burden. So that's extremely useful, except that one of the pieces of the way that they went around doing that study is they used the impact of waste disposal based on the grid, the spread of how waste is disposed of in the UK. And the thing about Bristol is it's quite different in the way it disposes of its waste. So compared to the UK, so we needed to tailor it for the Bristol approach. So what we had to do was then take a second life cycle analysis, which makes that much more explicit about what the different environmental effects are for each different method of waste disposal. So what we did for that was use a study called from the Slorak et al. Even 2019, which unpacks those different effects per tonne of food waste between putting it into landfill, sending it for anaerobic digestion, and sending it incinerating waste. And then each one of these has positives and negatives For example, through anaerobic digestion, you get energy generation from the gas that's produced, and you also get digestate, which then replaces fertilizers. But those things also come up with negative impacts, such as increases in particulate matter compared to other methods of disposal. So this is just a little diagram from Slurrock et al., just showing that there are different benefits and disbenefits depending on different methods of waste disposal. And that depends on is very much about how those benefits displace things like energy, displaces normal grid energy from UK production from non-renewable sources. So with all that information there, we then had to apply it to Bristol, the Bristol context. So our first point really was to discuss with our stakeholders actually how much food there is that's wasted in Bristol, and where does it go. So with those life cycle analyses, we had all the information about the resources that go into food, and then we had to work with people like Bristol Waste Company to try and understand what happens with food. So that's trying to understand when it leaves the household, it normally goes out in Bristol in two ways, which is through your normal domestic waste bin, but they also have a food waste recycling service. So a huge amount of food goes from the household into the anaerobic digestion plant just outside Bristol, and that contributes to energy generation for Bristol. So what we had to do then was map just how that happens, and then apply a value to those quantities. So we made some quite big assumptions to do this. The first being that there's a linear dose-response relationship between quantities of food and environmental impacts, where in real life we probably see there's more interactions between all elements of the system, for example, between different components of waste by different methods. And what we don't do, what this exercise was about understanding the non-market impact. So we didn't model for market effects, such as changes to food and waste disposal prices. If you reduce the amount of food waste that's being generated, what would that do to the cost of processing, for example, and the demand for waste processing? Also changes to if you stop consuming food and buying lots of food, what does that do to the food markets? And then what would the implications be for people's incomes? So there's a much larger project as part of Waste Fuel that looked at those macroeconomic impacts and tried to model those. So what we tried to do was just focus on the sort of microeconomic non-market effects of just the environmental impact of food waste and what possibly we could do to improve it. So one of the things here is just that I'm showing you the central reference figures, but there are very large ranges of uncertainty at kind of every stage of our calculations, so which we'll be defining a bit more in our paper. So here's just some very quick results from Bristol. So it's around 48,000 tonnes of food are wasted in Bristol every year. This is about £100 million worth of food every year for the whole city, and about 72% could have been eaten. So it's about 3.3 kilos per household per week, and about 11,000 tonnes of food are poured down the drain. So we know that in addition to leaving food at the edge of your household via your bin, people pour food down the drain and compost food as well. So we had to consider that. So this just illustrates that and a little bit more, that 41% of food goes into the black bins into Bristol. So while they have a really strong push there and they actually recycle a lot more food than is traditional in the rest of the UK, it's still only quite a small proportion of the overall food that's wasted. So, but we can see that home composting and sewer and how food is disposed of in those informal ways, the data isn't as good on those, so we've had to extrapolate that from other sources. Because of the nature of it, it's not as easy to track as just the quantities of information that are going through the waste processing plants. So just to compare with the national picture, Bristol is about equivalent to the rest of the UK. They actually waste slightly less avoidable food waste, but they recycle much more. And this is equivalent to around £40 worth of food and something per household. And something our stakeholders are really keen for us to do is to extrapolate the information into per household. What would this mean for people? So on average, a family would throw away about £730 worth of food a year. So, but this is excluding obviously all of the environmental impacts of food. So what we've tried to do then is describe some of those environmental impacts. So in terms of global warming is the biggest one here, which that 48,000 tonnes of food, and this is only the resources that are loaded into food before it becomes wasted, I should say. It's equivalent to around 110,000 tonnes of CO2 has gone into that food before it's even left the household to be processed. And that's equivalent to about £5.3 million. So the chart on the right shows you the different weighting if we apply a monetary value to that. So that's why it's really useful to use the monetary valuation techniques in order to understand the relative weight of these things. So it's quite difficult to understand what 320 tonnes of non-volatile organic compounds, what that's like compared to particulate matter or the effect on human health. So then we also unpack the effect of waste disposal in Bristol to try and understand this a little bit more. So, and here we can see there's a lot of positives. These are the green outcomes. So obviously the major one here is the primary energy demand, which is the contribution of that energy going to the anaerobic waste plant, and some energy from the incineration of food, and what that does to displace grid energy. So there are lots of benefits here, but there are also disbenefits, and the biggest one here is about particulate matter, and that's to do with the distribution from waste from the anaerobic digestion plant and from the energy from waste plant as well. So there are positives and negatives here, but what I wanted to compare first of all was the two different sizes of these kind of impacts, which is the first is the value of food production, and this is just the food that's wasted, compared with the value of waste disposal impacts. And this tiny little box in the centre is the actual size of waste disposal benefits compared to the actual resources that go into food. So what we wanted to do was unpack whether or not this question about recycling or versus reduction at source, which one's the best one to do. And when these scenarios were designed to emulate two really important interventions, which are try and reduce food waste. So the first one is a local one in Bristol. It's called Slim My Waste, Feed My Face. And it's about moving food out of those black bins and into the recycling caddies instead. So that's just more recycling, more effective recycling. And the second one is about reduction at source. And this is the Love Food, Hate Waste programme, which is a national programme to reduce food waste at source. And their aim is to change behaviour so that our food purchasing matches food consumption, so much more people are eating in a lot more efficient ways. So and what we're able to do with our results is then compare those two things, so we can see that there's trade-offs here for both approaches. So with 20% more recycling, we can see that about 3,900 tonnes of waste are going to food waste caddies for recycling instead of into the bins. And this means 113 tonnes less CO2 equivalent, less water and more green energy because we're moving food waste from energy from waste plant and an incineration plant effectively going over to anaerobic digestion, which is much more efficient and has much higher number of benefits for the environment. But this comes with more particulate matter and more marine eutrophication through nitrogen. So, but with looking at 20% reduction in waste at source, so looking at what would the effect be of consuming less, because we affect the whole part of the food cycle for every aspect of this, we're looking at 10,000 tonnes of less food waste compared to a much smaller amount, a much more targeted amount in the first scenario. So because of that, the savings are much larger. We're looking at 15,000 tonnes less CO2 and 86 tonnes less nitrogen every year. But we're also looking at a 20% loss of green energy generation. So, so to answer that kind of simple question, is it better to recycle or reduce waste? If we just look at a method of waste disposal, which is this chart here, you can see it looks like there's a lot of losses here for scenario 2, which is reduction of food waste at source. And that's mainly because those benefits around energy generation aren't there. So it reduces that potential for creating new energy through and displacing renewable energy. Sorry, for creating renewable energy. So, but if we compare them using the whole environmental burden of recycling versus reduction in consumption, so this is everything from the beginning of from land use and farming all the way through, the benefits of reducing food waste really do outweigh any disbenefits of reducing potential for generating green energy. So, so just to put this into context, and there's two key kind of limitations just to say about that. The first is the rebound effect, which was observed in this study by Celine Deep et al. In 2017, where they also looked at environmental valuation of food waste in the UK. They didn't have as many endpoints as we have, but they did find that the reduction in so the global warming impact of food waste might be any effect of reducing consumption might be mitigated in the way that people choose different goods. So they might, when they're being more efficient about what they eat, they might perhaps choose meat rather than bread, or they might choose a different alternative good, and that would have a different profile in terms of the impact that it might have. So, for example, if you're eating more meat, then you might eat that might have a much larger implication for the amount of CO2 that would go into that food. And also, people tend to. One thing that's been observed is people tend to buy more packaged food, which has other impacts for the environment. So the second big limitation in the study, Chapagain and James in 2011 looked at the carbon and water burden of food waste in the UK. So they estimated the global warming impact is about the same as the unit that we use, but that water footprint may be sort of 4 times larger in the resources that go into food than that was estimated in the Tonini study. And this relates to how we define the impact on water, looking at that life cycle analysis. So Tonini used something about just the depletion of water as a finite resource, whereas Chapagain and James were talking about water footprint in terms of all indirect and direct water use as a result of generating food. So those are two very different units, which might explain some of the anomalies there. Something we observed in our own study is that it looks like you get a lot more benefits from water savings from waste disposal than from what goes into food, and that just felt wrong. But just to have a look at this study to think about those different definitions. So just some other limitations of a study. It was quite a snapshot in time, and some of the challenges around what we're trying to do was trying to find comparable units, looking at the actual what goes into these units in terms of the units that are used by the studies to examine life cycle analysis and define, say, for example, global warming, and then how we actually assign a value to that. And that wasn't always directly easy. People tend to use different units for economic evaluation than they do for perhaps just defining the environmental impact of a thing. And so there are very broad uncertainties in some of the valuations, particularly around health. We've made some quite big assumptions based on the local mix of waste disposal methods and also the displacement of grid energy. And because this is a snapshot in time, what we haven't been able to anticipate is that the mix of renewable energy as part of the UK grid energy spread is likely to change quite significantly. And so that would affect whether or not that argument for more recycling and those benefits that we see from recycling, that would affect how much of those compares to the overall resource burden of food. And we went, again, we just to say we're not modelling market changes in these as an implication of these changes, so we're only looking at the environmental impacts. So just to summarise, I think one of the key things here is that it really does illustrate the waste hierarchy principle, which is that prevention of waste is so much more powerful than recycling. But either one of these things are really so much more better than just disposal. And so our baseline was landfill, and it really did just show that the importance of recycling food. Especially in the Bristol context, we're looking at about 30% of food is unavoidable, and so it has to be disposed of in the most efficient way. And this has just allowed us to kind of say, well, the evidence, the argument is there to try and get food out of that black bin and into caddies as much as possible, and to also look at how food is being disposed of via sewers and saying, is it possible that we could understand more about that and send that over there into the waste caddies as well. There was some evidence in the composition data that people were being more efficient when they started recycling food in caddies. So they were actually wasting less avoidable food that was going in caddies as a ratio, avoidable to unavoidable. But we weren't able to include that in our modelling at this point. So if you want to hear more, there's going to be a special issue of Sustainability Journal on some of the papers in waste fuel. But this is a really nice little article just explaining the waste fuel project. So just to give a shout out to that one. And I seem to have got a lot faster than I thought it was going to be, but perhaps it gives us more time to have a discussion. So please let me know if there's anything that's unclear you want me to expand on. But thank you for listening. It's really nice to be able to talk about our work.